Hello YouTubers, welcome to geekstips.com YouTube channel. My name is Lucian and in this video I am going to show you two of the most used temperature sensors in the Internet of Things homemade projects. If you are for the first time on this channel, in the future you are going to see a lot of video tutorials and reviews about technology, Internet of Things, electronics, Arduino modules and software development. You can find full reviews and complete tutorials with many code examples on my website geekstips.com. Just follow the links from the video description and you'll get there and you'll see valuable free information. Let's come back to our subject today. So in my projects I had the chance to use two of the most common temperature sensors that you can find over the market, over the internet, the DHT22 Temperature and Humidity sensor and the DS18B20 Temperature one-wire sensor. So many people use them in small projects, but I assure you they can be a very good choice for any kind of project that needs temperature measurements. So here we have both of them. You can see they are quite different. They have different shapes and different pinouts, but they at the end of the day they do the same thing. So the big one, this one, it's the DHT22. It comes from the DHT XX family, and it's produced by a company which is called Song Electronics Ltd, which I think is an Asiatic company. The DS18B20, it's made by Dallas Semiconductor company, a well-known company. So both of them are quite in the same range price. This one is from about somewhere between $2 and $9 or $10, and it can be bought in many versions. The price can differ from the one version to another because of the shape and the format and the enclosure. This one is the most basic version. It has a plastic enclosure and a plastic box, which is kind of squarish, cubic one. On the front side it has somehow like a grid of plastic. Inside there are both sensor, the capacitive humidity sensor and the thermistor for the temperature. I never opened one before, but I don't think you'll find many things under the case. So my voice, maybe it sounds funny, but I just made to get a flu. I'm a bit cold, but sorry for that. So this is DHT22 temperature and humidity sensor. As you see, it comes with 4 pins. The first pin is the VCC pin, which needs to be supplied between 3.3 volts and 6 volts DC current. The second pin is the data pin, which feeds the microcontrollers with logic signal, and on this pin you will get also the humidity and the temperature too. The third pin, it's not connected. I don't think anyone find it useful for something. And the last pin, the fourth pin, it's the ground pin, which you need to connect to your circuit to work. So 4 pins: VCC, data pin, and a not connected pin, and the ground pin. In the top part you can see kind of handy support. You can just use it using a screw to mount in wall, or put it in your case. If you have a project case, you can just use this board to just plug it there, to just catch him with a screw. Also on the back it has a double tape, sticky tape, which you can just use it to stick it somewhere, to glue it somewhere. Let's talk a bit about what this sensor can do. So as I told you, it costs between $2 and $9 or $10. It comes in different version. You will find it with AM2302 name, which stands for the wired version. It has a bigger enclosure and comes with ready-made wires. You don't need to solder or weld it on a PCB. It costs a bit mucher than this version. Also, I found it being soldered in a ready to use PCB with resistors and capacitors, and also the pinouts. This version, the plastic box, it's quite well made, but the pins seems very fragile. I don't like the pins at all. It seems to be very bendy. You can very easily break them down. So I think the producers should make stronger pins to these sensors in order to be less long product. So this is a downside. The pins are very bad quality, but as you can see on the table, I already use it in one of my do-it-yourself Internet of Things project. This is a little project which measures temperature and humidity and sends it over the internet to the ThingsPeak website. I use ESP8266 to collect the data and send the data over my internet connection to databases. Yeah, the wiring and the connections are pretty rubbish, but this is one of my first projects, so you cannot argue with me. Also, I have a little AMOLED display which shows live temperature data, so you can easily embed it in your project like I did here. Be careful that the welding temperature cannot be higher than the 260 degrees Celsius, because the circuits inside it will break. So you should proper align your welding iron when you mount it on the PCB. Other than that, seems quite well. I didn't have problems with it. Works pretty well and it gives the data quite accurate. I compared the data with weather station which I have, and it's quite expensive, and also came with a certificate for calibration, and the data was very appropriate, very close. So this is a good sensor. His accuracy is plus minus 0.5 Celsius degrees, and for humidity somewhere between 2% and 5%. Also, it has 0.1% resolution and 0.1 degrees Celsius sensitivity. It has no built-in alarm. The only technology it has, it's that it gives you the temperature and the humidity on the same channel. It's not waterproof. You cannot use it under the water. And the biggest downside on this sensor is that you need to wait at least 2 seconds until you do the next measurements. So be careful when you use it in your projects, because this may be a really important factor. So the sensing period, it's at least 2 seconds, and after that it gives you fresh data. You need to connect it using 3 wires, data, VCC and ground. Like I said, the DC voltage is between 3.3 and 6 volts. The power consumption is when the status is standby, it consumes like 50 microamperes, and when measuring, it consumes somewhere between 1.5 and 2 milliamps. It has a enclosure, a pretty strong box, as you can see. It has a mounting spot with a little hole for screw here, and the one of the biggest advantage is that it's fully changeable in your project. If one of these gives up, doesn't work anymore, you can change it very quickly. Just get it off and plug another one, and you don't have to change anything in your code. Everything will work naturally, so it's quite interchangeable, easy. The next one is the DS18B20, which I told you it's made by Dallas Semiconductor, and you can see that this sensor looks more like an electronic component than a real sensor. Actually, I put it here ordinary transistor just to compare with it, and just to show you that actually there is no difference between them. You can see that they are looking quite the same, has the same look and feel. So this is very small in comparison with the DHT one. You can easily embed it in your PCB boards. This is very handy when you need to measure temperature near a MCU or an electronic component which heats up very quickly. It's small enough to just plug it in there, and it will fit very well in small projects. So it has three pins, as you can see. The first pin it's for DC current, plus from plus 3.3 volts to plus 5 volts. This is the DC range that can be supplied with. The second pin is the data pin, and the third pin is the ground pin, which needs to be plugged in the circuit. But the most awesome thing about this sensor is that it can be powered by the data channel, and you can use it in your project just with 2 wires, so there is no need for the second power supply wire. You can pull the power from the data pin. Another big advantage is that this temperature sensor uses the one-wire technology from Dallas, and this means that you can use as many sensors as you want or as you need in your project, or just using one wire, so you can hook them up together, building a sensor network, and this will only require one GPU to measure them all, because inside this there is a silicon silicon serial which gives a unique address, and can be individually independent scanned and read from the MCU, the microcontroller unit. So this is quite awesome. A friend of mine soon he finished building his house, and he has a very large living room, like 60 meters squares, and he built a heating system in the floor of the living room, and he used 10 of these sensors to control every part of the floor, how much energy should send to every part of the floor using this kind of sensors. He built a network of 10 sensors using a single GPU from his Arduino Nano. So this is a very cool thing. But keep in mind that this sensor, you cannot change it as simple as you can change the DHT one. If you want to change this sensor, you need to rescan the network and find out his new address and change in your code. This is a downside. This temperature range, this has a temperature range between minus 55 degrees Celsius to plus 125 degrees. His accuracy is plus 0.5 degrees Celsius, but this is only between minus 10 degrees and plus 85 degrees. Below that, I don't know, this accuracy might differ, I think. Since the resolution can be programmable, is changeable from the code. You can program it from 9 to 12 bits. It has a built-in alarm, which is a very handy feature. You can use it to control other things which are based on temperature thresholds. It does have the one-wire network technology, which is cool. It's actually much smaller than the DHT one, and this can be an advantage in small projects. It exists over the market. You can find a new another version which looks like a probe and which is waterproof, and this is an advantage too. His sensing period is less than 1 second, and this may help you in projects that you need to measure faster than 2 seconds. It can be supplied with 3 volts to 5.5 volts, and his standby consumption is somewhere near 750 nanoamperes, which is quite cool. It's almost tends to zero power consumption. While measuring, it consumes 1.5 milliamps, and yeah, this is most of all I could find interesting about this sensor. Now it really depends what you need for your project. Before you buy these sensors, you really need to ask yourself a few questions in order to see which one fits better in your project. Like, do you actually need to measure the humidity? Is your project outdoor or indoor? Do you need one sensor or many sensors in your projects? What is your temperature range, the minimum and maximum? Should the sensor stay in high moisture or in water? At what intervals do you need to get the measurements? So another important thing is that if your project is powered by batteries, you really need to be careful at power consumption. This DHT22 it has a bigger consumption than the DS18B20. And after all, the budget matters. This one is quite it's a bit has higher prices than the DS18B20. So please give a look at my article. There are very detailed details there, and you can for sure, if you need to use them in your Internet of Things projects, reading my article should make your mind, should give you a proper vision about what decision you will make in choosing one of those two sensors, or maybe neither of one is good enough for your project. So this is all for now. You can find code examples and how to implement it with Arduino Uno ESP8266, and many examples how to scan the network via Arduino code, how to download libraries, how to install them, and how to hook up. Everything is in my website. Please follow the article, and for sure you'll find everything that you need there. So this is all for now. Hope that this video inspired you in making new projects. Also, this is my first video, so please do comment, make remarks, critiques and suggestions, and let me know what went wrong so I can improve my work in the future. If you like, don't forget to subscribe my video channel, give me a like and follow my Facebook page. Until next time, stay tuned, bye bye.